All right, so now we're going to move on to chapter 6, and we're going to do section 6.1. So chapter 6 is talking about polygons and quadrilaterals, and section 6.1 is talking about the angle sum theorem. All right, so before we start getting into any problems with 6.1, I want to talk about something that our book doesn't describe, so we're using a different book for this, but it allows for us to come up with the formula ourselves for the total sum of any polygon. All right, so each segment that forms a polygon is a side of a polygon. So in this case here, all of these segments that form the side of this polygon, they're all the sides of the polygon. All right, the common endpoint of two sides is the vertex of the polygon. So all of these corners are all our vertex, and they're all labeled A, B, C, or D. And remember, vertices, just like in triangles, are always with capital letters. So one of the important things that we use to come up with our formula is what's called the diagonal of, or is this a diagonal? And a diagonal is a segment that connects two non-consecutive vertices. So non-consecutive, so A, the very next vertex is B, so they're consecutive. C will be non-consecutive, D is non-consecutive, and E is consecutive because it's right next to A. All right, so non-consecutive means it's not next to it. So let's go through. They already drew a diagonal for us going from B to D, and B or D and C are consecutive, so we can't draw any diagonals there. So another diagonal that we can draw is from D to A, and we can't draw a diagonal here from D to E. All right, so we are going to use this now in order to come up with our question in a second. All right, before we get into anything else, another thing that we need to be able to do is you need to know the names of all of our polygons. So if I say a triangle, you know it's a three-sided polygon. Quadrilateral, it's 4. Pentagon, there's 5 sides. Hexagon, there's 6. Heptagon, there's 7. Octagon, there's 8. Nonagon, there's 9. Tenagon is, a decagon is 10, a dodecagon is 12, and then any other one that's not listed here, you would just say an n-gon, meaning if it's a 13-sided polygon, you would say it's a 13-sided polygon, or you can say a 13-gon. Either way, it's fine. But it's important that you freeze this, write this down, remember this table because we're using it now in this question. So it says, what is the sum of the interior angle measures of a heptagon? All right, so first you need to know what a heptagon is. And a heptagon is a 7-sided figure. All right, so we have 7 sides. All right, so it's something that you need to do. You need to be able to do. All right. Now, rather than me drawing an awful polygon, we're just going to go ahead and add a heptagon here. All right, so what I want you to do, and I want you guys to do this, right, is I want you guys to pause this and think about what we did with these diagonals and see if there's any way that you can come up with the total sum, because it says, what is the sum of the interior angles, meaning what does every interior angle add up to? So I want to see if you guys can identify how we can come up with the sum of all the interior angles of a heptagon or a 7-sided figure. All right, so pause this for a second and see what you guys can come up with. I'm going to go over it with you guys now. So what I'm going to do is I'm just going to pick one vertex. Doesn't matter. I'm just going to pick this vertex here. And I'm going to draw every diagonal I possibly can from that vertex. So this is a consecutive vertex, so I cannot draw a diagonal there. So I'll draw a diagonal there. I can draw one here. I know they're not straight lines, but I can draw one here, and I can draw one here. I cannot draw a diagonal here because that is a consecutive vertex. All right, now, what I want you guys to ask yourselves is, what shape did all of these just become? These are all triangles. And we know what a triangle adds up to. So we know a triangle has a sum of 180 degrees, 180 degrees, 180 degrees, 180 degrees, and 180 degrees. So we could just say, all right, 180 degrees, add it together, 1, 2, 3, 4, 5. But you don't want to do this for every single polygon that you have to do. So let's try and figure out how we can come up with a formula for this. So we had a heptagon, and a heptagon had 7 sides. And we created 1, 2, 3, 4, 5 triangles. So our formula that you will use is n minus 2, because if you notice we had 7 sides, and we were able to create 1, 2, 3, 4, 5 triangles. So we were able to create 5. So n minus 2, the number of sides we have, minus 2, times 180 degrees. And that is equal to the sum of the interior angles, meaning if we add up every single angle that I'm going to highlight here in green, so this angle, this angle, this angle, this angle, this angle, this angle, and this angle, they would equal to this. So let's plug it into our formula. 7 minus 2 times 180. Oops. 7 minus 2 is 5, because we know we have 5 triangles. And 5 times 180 is equal to 900. So that means all of these angles would add up to 900 degrees. All right, and that's the only example I'm going through with you on this video. You guys are going to do this example on your own, and you're going to hand this in. So we're on section 6.1. So remember the shared document that you did already. You should title this 6.1.1 because this is video 1. It's chapter 6, section 1, video 1. And then you'll put your colons. Now you can either show me the work by typing it out, but what's easier is if you guys just wrote it out on your notebook and then took a picture and share and attach this picture or put this picture into the document. And in this way I can see your written work and it'll be easier for me to go along with what you guys are doing. All right, but I want you guys to answer this question and share it with me. Remember, if you don't share it with me, you can lose points for your homework. All right, and that's it for this video.